In this video we will talk about the ellipse. The ellipse is one of our conic sections, and if you look at this picture right here, it shows you how the ellipse is formed with the cone. So we have the cone, and then we have a plane intersecting that cone at a slight angle, and that slight angle forms this oval shape, which we call an ellipse. Alright, the ellipse has a center. We call that center h comma k. It's wider in one direction and shorter in another direction. These lines that go through the center, the longer of those two is called the major axis. Okay. The major axis contains all the things that are really important for an ellipse. The major axis goes through the center, it goes through the vertices, and it also goes through what we call the foci. So we have a focus and we have a vertex. The vertex, each of those vertices are the endpoints of the major axis. In the other direction, we have a shorter axis, and we call that the minor axis. We do not have a name for the endpoints of the minor axis. The major axis can go in two directions. It can be horizontal, as we see in this picture, or the major axis can be vertical. So in this picture, the ellipse is vertically longer, so this axis we would call the major axis. So the major axis can be vertical or it can be horizontal. You'll notice that even if the ellipse is vertical, we still have the focus, the center, and the vertices that live on that major axis. It also still has a minor axis. Both of these are going to have a major axis and a minor axis. The major axis is always longer, and the minor axis is always shorter. We use letters to describe the distances between the things that we care about. Alright, so you'll see in the picture here we have a distance called A, we have a distance called B, and we have a distance called C. The distance A is always the distance from the center to the vertex. It's the same length in both directions. So if I go from the center to the left vertex and from the center to the right vertex, both of those distances are called A. If I go from the center to the endpoint of the minor axis, that distance is called B. And if I go from the center to each focus, that distance in either direction is called C. Alright, so let's come down here and let's fill this out. So a couple of things. The major axis is the longest axis. The minor axis is the shorter axis. The ellipse has the center called h comma k. What is the distance from the center to each vertex? Well, we call that distance A. The plural of vertex is vertices. The vertices are the endpoints of the major axis, and there's two of those. The distance from the center to the endpoints of the minor axis, well, we call that B. The distance from the center to each focus is C. And the plural of focus is foci. Alright, let's go back up here and talk a little bit more about these pictures. Alright, when we're looking at the equations of the ellipse, there's a few things that we need to point out. First off, we're going to see that we have the x minus h, so x and h still go together, and we have the y minus k, so y and k still go together. And this is true for both of these equations. You'll notice in these equations, both x and y variables are squared. So they're both inside of parentheses being squared. They're both on top of fractions, so we'll notice that, and they both have a plus sign in between them. So this turns out to be significant later. They both have a plus sign, so we're adding in between those fractions. Both of these equations have equal 1. And so this is what we call the standard form of an ellipse. So the standard form of the equation of the ellipse always has those two fractions added together and then equals 1 on the other side. Alright, something else that we see at the bottom of the fractions is we see a squared and b squared. Remember, a is the distance from the center to the vertex along the major axis. We said the major axis was the longest axis, so the distance A always turns out to actually be longer than B. So when we look at the denominators of these two fractions, the value A is always bigger than B, so A squared will be, for our purposes, always bigger than B squared. Okay, so it has an A squared and a B squared, the A dealing with the major axis, the B dealing with the minor axis. So I'm just going to write here that for our purposes, the A squared will always be larger. Now something else, how do we know the orientation? So how can I look at the equation and tell if the major axis will be vertical or horizontal? Okay, so that information is actually going to come from the fraction and the denominator. So if the major axis is horizontal, think about which axis when we're graphing, okay, which axis is horizontal? Okay, so we're going to relate it back to something we already know, we're familiar with. The x-axis is the horizontal axis. If the major axis of the ellipse is going to be horizontal, what we're going to see is that the larger value, or the a squared, the larger of those two denominators, will be underneath the x variable. So it will be part of the x fraction. All right. How do we know if the major axis is vertical? Well, if the major axis is vertical, what we're going to see when we look at that equation is we're going to see the larger of those two numbers, larger of those two denominators, that number is going to be larger underneath the y fraction. So when determining the orientation of an ellipse, we look toward the bigger denominator and we see what variable it is underneath. Okay. Why is the y fraction corresponding to a vertical major axis? Well, think about this. The y-axis is itself vertical. Sometimes we say parallel. Let's talk about that. Means goes in the same direction, right? Has the same slope. If the major axis is horizontal, sometimes we will say parallel to the x-axis. So the major axis will be parallel to the x-axis, and therefore the larger number will be part of the x fraction. In this case, if the major axis is vertical, we would say that the major axis is parallel, or opens in the same direction, has the same slope as the y-axis. Therefore, the larger number, the larger denominator, will be part of the y fraction. Alright, so the last thing that we end up looking for, we'll notice that in those equations we don't see anything about c mentioned. How do we find the c value? Well, if we know a and b, then we can plug those values into the formula to find c. So c squared equals a squared minus b squared is the formula for how to find c. Alright, notice that in between a squared and b squared in that formula, you are subtracting. Okay, so it's actually the opposite of the sign in between the fractions. In between the fractions and the equation, you're always adding. In the formula for finding c, you will be subtracting. Alright, now in the next few videos, we're going to be taking all of this information about ellipses and what a, b, and c mean, and the orientation and the equations, and we're going to apply them to some problems. So you might need to refer back to this page.